Okay, so what is the next question on the menu today? The next question is, what is the derivative of secant squared of x? First, let's unpack this a little bit. Secant squared of x is equal to secant of x, but squared that. And secant is 1 divided by cos x. It's the reciprocal. Now, why do we have secants in the first place? A long time ago, in a galaxy that we currently live in, there were mathematicians who used, like, we needed these reciprocals, but they didn't have calculators at the time, so they had tables. And I think the reason why we have secant instead of just always using this is because it's kind of hard to calculate the reciprocal. So we made separate tables for the reciprocals, and we gave them appropriate names like secant, cosecant, cotangent. Yeah. Now, why do we still need them at all? Probably not. Like we could replace all of them with like regular cosine and tan, but that would be way too easy. We like things to be hard because we go hard in the paint. Okay, so if we're trying to find the derivative of secant squared of x, that's the same as trying to find the derivative of this. Yeah, so that's essentially what the question is. D over dx, 1 over cos x squared, which is the same as d over dx of cos x to the power of -2. So when you bring the cos from downstairs to upstairs, that's to the power of -1, and then you square that to the power of -2. Okay, so this is not too difficult to deal with. This is like a chain rule situation. All right, so let's hit it with the chain rule. The chain rule says that when you have f, oops, I gotta say it, like when we're taking the derivative of f of g of x, like the composition of functions, here our composition is like cos of x is the g of x, and the -2 is the outside. What this really is just gonna like verify to make sure this is super accurate. Never hurts to double check. So this is really just you take the derivative of f and you keep the natural inside without changing it. F prime of g of x. But you also have to multiply this whole thing by the internal derivative g of x prime. Okay, so let's apply that principle to the chain rule to what we got right here. So our d over dx to show derivatives is of cos of x -2 is equal to, well, first let's do the first one. So it's a polynomial to the power of -2. So the rule is that we're going to multiply it by the power and subtract 1 from it. So -2 is equal to cos of x to the power of -3. And we have to multiply that by the internal derivative of here. So what's the derivative of cos x? Glad you asked. That's negative sine of x. Okay. Hey, if you look closely, the negative here and the negative here, they neutralize each other out to be positives. So this is just equal to 2. Okay, you see how cos is to the power of -3? The negative means that we can send it downstairs. So we got 2 2 over cos of x, but cubed. And on top we got sine of x. Okay, now can we simplify this a little bit farther? Sine x divided by cos x is equal to tan x. So we can eliminate the sine from the top and remove one of the coses from the downstairs and just get tan. So we get 2 tan of x over cos squared of x. Now let's say you do not want to see a cos squared of x at the bottom. Well, you can easily move that to the top by converting it into a secant. Equals 2 tan of x secant squared of x. But it's perfectly reasonable to leave your solution like this. That's perfectly reasonable, and this is perfectly reasonable. Okay, they mean the exact same thing. Type it in your calculator if you don't believe me. Yeah, so it appears that the solution, secant squared times tan times 2, yup, looks good to me. So here, the above solution is correct. Good job. Super. Beautiful.